So let's see how to do what is problem number 5 on 8th do conservation of momentum part 2 speed here. So again, all of these you wind up setting up basically the same way. Here we have a bomb that's moving. They don't tell us how fast. And again, don't get confused by mass 1 and mass 2. They're basically saying, oh, these two pieces are traveling together. This piece is going to be 4 kilograms, that piece is going to be 3 kilograms. They do tell us the speeds of each of these afterwards, so we can find these. Let's take mass 1 is equal to 4 kilograms here, and mass 2 is equal to 3 kilograms, and we can find the momentums of each of those. That's easy enough to do because we just do mass times velocity. So this piece has a momentum of negative 20, 4 times negative 5, and this piece has a momentum of, and we'll call this momentum 2 prime, of 3 times 12, which is 36 kilogram meters per second. And we'll call this momentum 1 prime, the momentum of object 1 afterwards, the momentum of object 2 afterwards. So what is the total momentum afterwards then? Well, whoops, we'll just get rid of that 2 to make it the total momentum of the system afterwards. Well, it's these two added together is the total. So negative 20 plus 36 is 16. That means we have a total of 16 kilogram meters per second of momentum afterwards. That means over here, our system needs a total of 16 kilogram meters per second of momentum because it can't change, right? That's the whole thing. The momentum's conserved. So whatever it was in the end, that's what it had to be in the beginning. So this one's going backwards. We're taking the stuff in the end to find the stuff in the beginning. So now you can set this up. If we know the momentum and we know momentum is mass times velocity, we can figure this out. So plugging in here, we got a momentum of 16. Now what's the mass? These two things are moving together. So I'm gonna think of them as having one mass here of 7. And then that is gonna be times the velocity in the beginning. So now all we have to do is to find that by taking 16 divide it by 7, and that is, let me type it into the calculator here because I think I have you do it to the nearest 10th, 2.28, blah, 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 blah. So it's going to be 2.3 meters per second is how fast it's going. Now, again, you could set this up with the big way that we have been doing it, the huge equation. You can say, without thinking, that the momentum in the beginning is equal to the momentum of the system in the end, and that is to say the momentum of object 1 before plus the momentum of object 2 before is equal to the momentum of object 1 afterwards plus the momentum of object 2 afterwards, and that would be the mass of object 1 times the velocity of object 1 plus the mass of object 2 times the velocity of object 2 times the mass of object 1 times the velocity of object 1 afterwards plus the mass of object 2 times the velocity of object 2 afterwards. And then you could plug everything in here. Because we know mass 1 is 4, we're looking for that velocity. We know mass 2 is 3, we're also looking for that velocity. And I'm not going to write 1 or 2 because they actually have the same velocity, so I'm just going to get rid of that. And over here, mass 1 is 4, we know its velocity is negative 5. Mass 2 is 3, and we know its velocity afterwards is 12. And if you work through and solve for v here, you'll have to factor your v out. You'll get the same thing, that v is 2.3. So either way, it's ultimately the same thing. You're just doing steps in different orders.